So now let's look at volume of cones. In a lot of ways, a cone has some things in common with a cylinder and has some things in common with a pyramid. Right? So like a cylinder, a cone has a circle base. Like a pyramid, it only has one base. So a cone has one circle base. Right? And so this would be the base. Opposite the base, just like the pyramid, it has that one vertex. This is also called apex. Apex just means the highest point. Right? So it has one circle base and then a vertex opposite the circle base. Right, so the formula for the volume of a cone can be determined from the formula, the volume formula for a cylinder. We must start with the cylinder and a cone that have equal heights and radii as shown in the diagram. Right, so here they both have the exact same radius and the exact same height. If we filled the cylinder with water, how many cones with the exact same radius and height as the cylinder could be filled? Well, if this were live, I could show you, but I can show you a picture. Right, so volume comparison, cone and cylinder. This means it takes the volume of 3 cones to equal 1 cylinder. Looking at this in reverse, each cone is 1/3 the volume of a cylinder. So just like the pyramid is 1/3 the volume of a prism with the same base and height, the cone is 1/3 the volume of a cylinder with the same radius and height. So since a cylinder's volume formula is the area of the base times the height, and we know height's the distance between the two bases, then the volume of a cone is 1/3 that formula. Right? So it's 1/3 the area of the base times the height of the cone. But specifically, the cylinder's volume formula is pi r squared times h, right? Because the base is a circle. Right? So that's for the cylinder. And so the cone is going to have the same volume except it's going to be 1/3. Right? So this is because the base of a cone is a circle. Right? So the formula for the volume of a cone is going to be 1/3 times pi r squared times the height of the cone. And here we have that pictured. So the volume of a cone can be calculated in the same manner as the volume of a pyramid. The volume is 1/3 the product of the base area times the height of the cone. Since the base of a cone is a circle, the formula for the area of a circle can be substituted into the volume formula for the area of the base. So the volume formula for a cone, 1/3 pi r squared times height, right, where r is the radius and h is the height of the cone. So if you thought cylinders was easy, it's the same formula, just dividing by 3. All right, so we want to find the volume of the cone with a height of 12 feet and a radius of 4.5 feet. Right, so radius here is 4.5 feet. The height is 12 feet. All right, so the volume is 1/3 times pi times the radius, which is 4.5 squared, and then times the height of the cone, which is 12. All right, so first we have to square the 4.5. All right, so that would be 20.25. Let's just multiply the 12 times the third. That one's pretty easy, right? So that would be 4 pi times 20.25. Right? So that would be 4 times 20 is 80, and a fourth of 4 is 1. So the volume here is going to be 81 pi feet cubed. And there we go. That's all there was to finding the volume of the cone. Let's do a few more. Right, so now, though, we're going to have to look for the height of the cone. So find the volume of a cone with a slant height of 50 and a radius of 30 centimeters. If we don't know the height of the cone, we will have to use Pythagorean theorem to find it. And this is always going to be set up the exact same way. Right? It's always going to be slant height squared, just like the pyramid, right? And the slant is on the outside of the cone. So this is the slant. The height is on the inside, right, which is right there. All right, so we're going to have slant height squared equals, and this is always going to be set up the exact same way, radius squared plus the height squared. Every single time. So if we were looking for surface area and we weren't given slant height, we'd have to solve for slant height. If we're looking for volume and we're not given height, we'll have to solve for height. All right, so the slant height is 50, so 50 centimeters equals 50 squared equals 30 squared plus h squared. 50 squared is 2,500. 30 squared is 900. If we subtract 900 from both sides, that would give us 1,600. And then if we take the positive square root only, because measurement has to be positive, we get 400 is the height of the cone. All right, so now we can find the volume. So remember, if you only know the slant height, you must use Pythagorean theorem to find the height to calculate the volume of a pyramid or cone, because volume is the inside measure and slant is on the outside. All right, so now let's find the volume. So volume equals, so the radius is right there, it's 30 centimeters. So volume equals 1/3 times 30 squared, and then the height is 400. All right, so 30 squared is 900. 900 divided by 3 is 300, and 300 times 400 is going to be 12 with 3 zeros. So 12,000. No, wait, excuse me, 4 zeros. Right, because the 300, so 1/3 times 900 is 300. 300 has 2 zeros. 400 has 2 zeros. So 3 times 4 is 12, but with 1, 2, 3, 4 zeros. There. So 120,000 pi. So this is a huge cone. Well, it's only in centimeters, so maybe not as huge, but still pretty big. Centimeters cubed. And there we go. That one's done. All right, let's solve another. All right, so we're going to find, actually this is on my last page, we're going to find the volume of these two cones. All right, and I am almost thinking that I would like us to solve one more time for the side. But I'm going to have to change that because I don't like that number. So I'm just going to change that real quick. So that way we can solve one more time for the height. So this will be all right, it'll be 10. Now, there's no reason it couldn't have been 15, but I am going to look for a nice number. All right, so a perfect square. In other words, this is going to be a Pythagorean triple. All right, so there we go. So let's look at the first one. The first one is an oblique cone. And that just means that the vertex here is not directly over the center of the base. Right? Surface area is really tough on some of the oblique figures, but volume is easy because it's the same whether it's oblique, like this one, or a right cone, like the other one. A right cone just has the vertex directly over the center. All right, so either way, the volume is going to be 1/3 times pi times r squared times the height. The only thing is, if we are on an oblique cone, the height is outside the figure, right? So we still have a right triangle here formed by the radius, the height, and some slanty line in the figure. But it's this here isn't anything particular, right? So that's not height, right? Because it's not perpendicular. So this is not, right? That's not a right angle. So that's not the height. This one is a right angle right here. So that is the height. So anyway, the volume is 1/3 times pi times the radius 4 squared times 14. So that would be 1/3 times pi times 16 times 14. None of those are divisible by 3. So I'm just going to multiply 16 times 14 and divide by 3. And we'll round. And that would be 74.667 centimeters cubed. All right, so now let's look at the right cone. All right, so first we're going to find the height. All right, so the height is, so it's going to be slant height squared. And this is the slant. So by the way, we'll only ever find the height really on the right cones, not the oblique. Right? So the slant height is the height of the outside part, right? And the height is perpendicular to the base. It's the inside, it's the distance from the base to the vertex. We use slant height if we're finding the surface area, because we'd be finding the measure on the outside. We use height for volume because we're finding the measure on the inside. Excuse me. So slant height squared equals radius squared plus height squared. Now we're not given the radius, right? See, because we have that line goes all the way from one side through the center to the other side. So that is the diameter. So the diameter equals 12 centimeters. The radius would just be half of the diameter, or half of 12 centimeters. So the radius equals 6 centimeters. That's right, like that. All right, so we have 10 squared equals 6 squared plus h squared. That's 100 equals 36 plus h squared. Subtract 36 from both sides. 64 equals h squared, and then we take the square root, but we only want the positive. So 8 equals the height of the cone. There we go. All right, so now we can find the volume. The volume is equal to 1/3 the radius squared, all right, so that would be, the radius is 6 centimeters, so that's 6 squared times the height, which is 8. Right, so that would be 1/3 times 36 times 8. 36 is divisible by 3. 36 divided by 3 is 12. And 12 times 8 is 96. Oops, we forgot the pi. Well, I didn't forget to write the pi. Oh, it was a bad day for pi. Bad day for pi. So here on the first one, no pi. Don't forget the pi. You can't forget the pi. Right? If you need to, underline it. I'm looking at a big board, so I guess I forgot to write it down. But here, I wrote it as I finished my answer, but no place did I put pi in here. So we'll just squeeze in pi. But I remembered. All right, so 1/3 of 36 is 12. 12 times 8 is 96. So 96 pi centimeters cubed. There we go. Those answers look good. All right, and if you have any questions, let me know. This is the end of finding the volume of a cone. Thanks for watching. Bye for now. And then next video will be spheres. In spheres, I have to do surface area and volume. If I don't teach you the surface area of a sphere, the volume doesn't make a whole lot of sense. All right, well, bye for now, and thanks for watching.